Good afternoon, everyone. Welcome to our grower lunch break with University of Maryland College Park and University of Maryland Eastern Shore and University of Delaware. We have a really interesting topic this afternoon. I guess I should tell you I'm Jennifer Timmons with UMES, and of course we have Jenny Rhodes and John Moyle with the University of Maryland College Park Extension. Welcome, everyone. We have a interesting topic, I think, this afternoon for everyone. We are going to have Dr. Simon Zebelo. He's associate professor at UMES. He's got a background in entomology, probably, and other things that I don't understand as well. And he's going to talk to us today about some integrated pest management practices that we can use in commercial poultry production. So Dr. Zebelo, I'm going to turn it over to you.
All right. Good noon. I have to say that, I guess. It's noon. Thank you for the opportunity, Dr. Timmons, John, Jenny. This is really good opportunity to connect with our stakeholders. So today I'm going to talk about integrated pest management for poultry production in general, but particularly I will focus on life cycle of the houseflies because they are very important pests. Of course, they are nuisance pests. So we'll focus more on this presentation on houseflies. So what are the arthropods in poultry operations? So flies, beetles, mice are often major concerns for commercial poultry operations in the Northeast United States. So the high density and confined housing system used in poultry production creates a condition that favor the development of different pests. Just to name some, like houseflies, different types of houseflies, housefly, little housefly, black garbage flies, stubble flies, blowflies. There are different types of flies that we can name. And also there are other very important pests like mealworms or darkling beetles, hide beetles, and very important pests of birds is also the northern fowl mites. So these are most common pests that we encounter in poultry operations. So why are the arthropods are pests? First, what is a pest? A pest is any animal or plant harmful to human or a human concern. In other words, any organism, whether plant or animal, that makes a discomfort to human being, we call it a pest. So as I've mentioned, flies are number one pests, I can say, that annoys people, that transmits disease, and also it has other implications. There are some reports that coming through that houseflies even impact the number of eggs laid by chickens. There are reports that say that. But today I'm going to focus why flies are important. Fly population may create a public health nuisance around the farm and nearby communities. Sometimes there may be also some litigation. Some people might press charge because of this fly infestation that comes from poultry production. So that's an issue. That's why we call them a pest. Houseflies can transmit more than 100 human and animal disease causing organisms. Viruses, bacteria, protozoans, fungus can be transmitted by houseflies mechanically or they vector them on their physiological system. Also, as we all know, avian influenza is spread principally by contaminated shoes, clothes, and equipment. But there are reports that also this virus has been isolated from adult houseflies. So that makes this pest very, very important. Understanding this pest, identifying these different types of housefly is important. And the second important pest in poultry operation is this mealworms or darkling beetles. So causes structural damage to poultry housing and create community problems at the time when the house clean out. So how they make a structural damage is these beetles, they bore on the house, on the woods, on the timber, which the poultry house is made from. They bore just not to eat the wood, just want to create a very safe, a comfortable place where they can pupate, they can spend the winter. So at the same time, they just cause that structural damage. But at times, these beetles also can go outside of the poultry house, especially during clean out. They may go to the community around and then creates a litigation problem. And also, these beetles also transmit or vector or a reservoir of several poultry disease pathogens such as acute leishmaniasis, Mark's disease, fowl pox, and numerous pathogenic like Salmonella, E. coli can be also transmitted by this beetle. Another pest is these fowl mites, which are large northern fowl mites population, can cause direct economic losses by affecting bird health and production. This is very serious pest of poultry production, especially in breeding houses where they have a very close hand-to-hand or bird-to-bird contacts. These insects are really important. So, but we are talking about pests here, okay? There are also beneficial insects in poultry operations. There are some beneficial arthropods in poultry houses, like micromites, aprodid mites, hister beetles, another very important predator of housefly larvae, especially the early instar, early growth stage of housefly larvae or the maggots preyed by hister beetles. And then there are different tiny, very tiny, sometimes you may not notice them, very tiny wasps, Muscoidephrax raptor or Raptorellus. They are very important, very effective parasitoids. They lay their eggs on the puparium of houseflies. So these are also present in our poultry operations. So whenever we think to rid of houseflies by pesticide, we have to also take into account the presence of these very important beneficial arthropods. Another thing that I just want to touch a little bit is poultry housing and pest problems always associated. For example, there are 3 types of poultry operations: cage layer, there are stacked cages where the birds live, and then here we have high manure accumulation under this cage, which is a very great or suitable breeding spot for houseflies mainly, but still there may be also some beetles and mites too, but that is caged layer operation most of the time encourages a lot of flies. Broiler production, most of the times an open area, we can see there are litters, dry litters, which also triggers the presence of these darkling beetles. And also the close proximity of the hens leads to mites. Of course, the black garbage flies are also high in this type of broiler type of production. And in breeder houses, mainly we see, of course, there are some flies and beetles, but mainly in a breeder's house, you would see issue with these foul northern long mites. This because there is a very close body contact between these birds in these breeder houses. So different types of poultry operations may encounter different types of pests. So today, I'm not going to discuss about the darkling beetles or mites. We may have another session about that, but I'll focus on houseflies. Houseflies, Musca domestica, as the scientific name of houseflies. The suitable fly breeding conditions are present year-round in high-rise houses because long-term manure accumulation and controlled temperature. Temperature is a factor for many insect pests, either in agriculture, in other crop production system, poultry production system, temperature is the factor. So in high-rise houses, long-term manual accumulation is there, and the temperature is very conducive for flies. So that's why they survive the winter, they survive the summer, the high temperature. So the effective housefly dispersal range appears to be from 1/2 mile to 2 miles, but distance as great as 10 to 20 miles have been reported. So imagine if 10 to 20 miles reported, the issue with nuisances of these flies could be not just limited in 2 miles. It may go up to 10 miles, 20 miles, okay? So the nuisance density highest closest to the source, closest to the poultry production or poultry operation system. Houseflies can transmit more than 100 human and animal diseases and causing organisms like fungus, bacteria, virus, protozoans can be transmitted by houseflies. So how do we identify houseflies? Houseflies are non-biting flies, about 1/4 of an inch long, mostly dull gray in color, as you can see here, with 4 black stripes in the thorax. See, there are 4 black stripes in the thorax. Houseflies breed in manure, spilled feeds, and other moist, warm, decaying organic material. Each female can produce up to 6 batches of 75 to 200 eggs at 3 to 4 day intervals. That's a huge number. Just a single female housefly or adult housefly lays 6 batches of eggs. Each batch has 75 to 200 eggs. So they lay within 3 to 4 days. So these eggs laid in cracks in surfaces under the surface of breeding material, even sometimes under the surface of piled manure. So those are very important place for the housefly where they lay their eggs. So let's see the life cycle of houseflies very briefly. So this is what looks like housefly life cycle. We have the adults lay eggs, and then the egg hatches between 12 to 24 hours within a day, and then enters to the first instar or first larval growth stage. And then from first larval stage to the third larval stage, it takes 4 to 7 days, and then enters to the pupal stage. And then from the pupal stage, it emerges within 3 to 4 days. And then the adult starts flying and laying eggs. Like what I mentioned before, it lays 6 batches of eggs. And then in each batch has between 75 to 200 eggs. That's a lot of numbers. That's why you see a lot of flies in short period of time, okay? So the life cycle is temperature dependent, requiring 10 days at 85 degree, 21 days at 70 degree, 45 days at 60 degree to complete this life cycle from adult to a pupal stage, and then again new adults. That life cycle or lifespan depends on the temperature. The higher the temperature is, the shorter the day of the life cycle. The lower the temperature is, the longer the life cycle to be completed. Okay, and adult flies, an average of 3 to 4 weeks. They live an average 3 to 4 weeks, but they can live twice this long, maybe 2 months they may stay. And most of the time, adult flies are active when the temperature is between 80 to 90 degree. And then they are, at nighttime, they are inactive if the temperature goes down less than 45 degree. Okay, so this is in general about housefly life cycle. Most of flies, all different types of flies, they share somehow similar type of life cycle. So I don't want to repeat when we discuss the other type of house flies. We are not going to come back and see the life cycle, but because almost the life cycle is similar. So let's see little housefly, Orphania consularis. A little housefly resembles the housefly, but it's smaller and has 3 brown stripes on the thorax. And then the housefly has 4 stripes, but the little housefly has only 3 stripes on the thorax. And then the other difference is like the housefly, the little housefly may invade homes in nearby residential area, but it tends to be less annoying since it does not settle as readily as on the food or people. And another difference is in housefly, the larvae are maggots, but in little housefly, they look like a pupal or they are hairy, as you can see. They are larvae of little houseflies. So quite different from the maggots. The maggots are for the housefly, which are larger. They look more worm-like, but this one is kind of crawling insects, or they at times they turn brown. They look like a pupal, even though they are larvae. The other fly that commonly inhabits in poultry operation is black garbage fly, which found in large numbers around poultry facility. They are shiny bronze black and are little smaller than houseflies. The life cycle is similar to that of housefly and ranges duration from 14 to 45 days. Unlike the housefly, a little housefly or black garbage flies tend to stay on their food source at night rather than rest on the ceiling or outdoor vegetation. Black garbage fly larvae, which closely resembles housefly larvae, and have been known to exterminate housefly larvae, but we cannot really consider them as a beneficial, even though they exterminate the maggots of housefly larvae, because they do the same. They are pests. They annoy people. They transmit disease. So even though somehow at high moisture, when we have manure with high moisture, the larvae of this black fly, they might serve as a biological control, but still we consider them as a pest, even though they do those extermination service. Okay, so after we have seen these 3 types of flies, let's talk a little bit about integrated pest management of flies. So let's define what is IPM. IPM is a philosophy that utilizes all suitable pest management techniques and methods to keep pest population below economically injurious level. In other words, IPM is just integrating different pest management techniques, biological, cultural, pesticide, but it has to be socially acceptable, environmentally friendly, and economically affordable way. That's another definition of IPM. So a very important term here is the term, the statement in red, economically injurious level. So the population of flies has to stay below threshold level, below the level that bothers people, bothers community, below the level that can transmit disease. Okay, so let's talk about a little bit about economic threshold level, economic injury level. So here we have in the x-axis the time to which the poultry operation runs, and then here we have pest density in the y-axis. Then the population of pests fluctuates up and down, but when the population passes the economic threshold level, and before it reaches to economic injury level, we have to apply pest management, especially chemical control system. We can keep the fly population below economic threshold level around here by using cultural method, by managing manure, managing moisture, sanitation, or using biological controls. But if the population of the fly passes the economic threshold level, before it reaches economic injury level, we must use a chemical or a pesticide control in order to keep the population below economic threshold level. So this is very important always, because that level, the economic threshold level, this blue line that you see here, has to be determined either through research, through a very clear monitoring system. So in the next slide, we will see what are the monitoring system for housefly. How do we monitor them? Because we have to have standardized quantitative method for monitoring fly numbers should be used for making control decisions. We cannot really rely on our visual appraisals, because visual appraisals are just subjective. Most of the time they are misleading. So we have to have a method. For example, we have to use baited jug trap. These baited jug traps be supplemented with fly pheromones. And then the fly pheromones attract the fly, and the fly enters here, they cannot escape. So if we collect 250 flies per week per jug, that is the economic threshold level, or the nuisance threshold level. So we have to apply the control measure. And also we can use yellow sticky cards. So the yellow sticky cards are very easy to use, both sports card and yellow sticky, very easy to use. The only thing is they may cover by dust, or they may trap a lot of flies, so as their efficiency might reduce it. But relative to a baited jug trap, which is a tedious, you need to empty these jugs weekly. They need a lot of work. They need pheromones. These two types of monitoring system, the yellow sticky card and the spot card, are very easy. So with yellow sticky card, 100 flies per sticky card in both sides of the sticky trap, that is commonly regarded as the threshold level. In spot card is a white paper which normally fastened in the post. So we can count the number of excretes or regurgitates from flies. If we have seen 100 fly pecks per card in a week, that is the threshold level that we need to apply a control measure. So these different types of monitoring system has to be employed in order to decide when to spray, when to apply the insecticide in order to control houseflies. But for now, I'm going to focus a little bit more on the yellow sticky card, which is commonly used to monitor flies. So an IPM program monitor pests and continuously track population trends over a period of time. So yellow sticky cards, approximately the size is 3 inches by 5. These cards do not contain an attractant, just sticky material on both sides of the card to trap the flies with land on it. Very simple. It has to be placed at least for 32 feet high-rise house. We may need 3 traps. So these 3 traps placed, as you can see here, around different locations. So for successful monitoring depends on where the barns of the monitoring cards are hung. Preferred locations are those where flies tend to congregate or rest. This is usually any calm area along walls, below air inlet baffles, or near posts. The end of the barn where the feed hoppers are located is often preferred location for flies to gather. And then we need to avoid placing these cards in front of fans, air inlet openings, or near climatic disturbance like drafts, heat sources. We have to avoid these locations. Other than that, especially the feeding hoppers are located in the rear area. That's the best place where to put these traps for monitoring of flies. So on monitoring, we have to count the number of flies per week and then record that number in order to decide the economic threshold level. So the common threshold level is an average 100 houseflies per cart, as we have mentioned it before. But this threshold made lowered or increased depending on proximity to neighbors. That's very important to consider. How far is the poultry operation from residences, from the community? So in order to decide this 100 houseflies per, and also, is there any risk? Is there any infestation of even avian flu or other disease? Also determines this threshold level. The time of the year or the cycle of birds, cost of insecticide determines the threshold level of the houseflies. So any farmer who raises chicken has to have their own threshold level that is most of the time determined through a kind of mini research, how far they are from the residence, restaurants, shopping center, all determines that. So some people, for example, if in the meat processing houses, the threshold level is very low, very close to zero. They don't tolerate a single or two flies nearby operations. So they have to really aggressively apply chemicals in order to reduce the population down to the threshold level. So this number is just commonly used in many poultry operations, but that number varies depending on proximity of neighbors, potential transmission of pathogens, time of the year, and cost of insecticide. So that's the take-home message. I have this example that's been used in Ontario. So this is weekly number of traps in sticky yellow, and then you see here in the 12s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In the 12, 11, 12 weeks, there is huge infestation of flies. So that's the time when the threshold reaches where they have to apply chemical pesticides. So this is just an example. So coming back to this very interesting graph, what we can do if to maintain the population of flies below economic threshold level is the one in green here, cultural control, and then the one in blue, the biological control, just to maintain them below economic threshold. But if accidentally the population of flies passes the economic threshold level and reaches or about to reach the economic injury level, we must use pesticides. Pesticides are always the last resort in order to keep the population of the flies below economic threshold level. But in order to maintain them below economic threshold level, we have to really have cultural practice, includes manure management, moisture control, sanitation, and also introduction of some predators or parasitoids that maintains the population below economic threshold level. So now we are going to see these different control measures, starting with cultural methods, cultural or physical control method. The first technique of fly management in poultry operation is manure management strategy. There must be there always very good practice for managing manure. So dry manure that has 50% moisture or less reduce the suitability for fly oviposition and larval development. So it also provides that less than 50% moisture in the manure provides a desirable habitat for beneficial predators and parasitoids. So maintaining the moisture level of the manure in the chicken house has many advantages. It's reduced the flies and also encourages or provides a conducive environment for the beneficial insects. Fresh poultry manure has approximately 75 to 80% moisture, and flies can breed in 50 to 80% of moisture. So that moisture level has to be really avoided in order to reduce the fly population. So moisture levels are affected by leaking waters, or the waters may leak, condensation from non-insulated overhead water lines, improper ventilations. Ventilation is recommended in a chicken house. Every 60 feet, there must be a ventilation in order to dry the chicken house. Also, there are some seepage from the exterior may add some moistures that will create a condition where flies breed. During spring and summer, when fly and beetle dispersal is major concern, manure that must be removed from the building can be piled and tarped to kill developing pests. Tarped means just has to be take away to the outside and then cover them with plastic, and then they have to expose it to a direct sunlight, which increases the temperature and kill all the fly larvae inside that. So those piled manures would be relatively free of some fly larvae. And the other control measure is biological control measure, which always helps to reduce the population below economic threshold level. So in the Northeast, micromites is a major predator in caged layer operations. The micro-hilled mites feeds on housefly eggs and first instar larvae, or the first stage of the larvae. It can consume up to 20 housefly eggs per day. For any appreciable impact by the mites, large mite population are required. About 3 to 4 weeks of manure, about 3 to 4 weeks old manure accumulation are necessary for mites to become established well. These mites can be purchased from different companies like IPM Inc., somewhere in Pennsylvania, and then also they have office in New York. They can be purchased easily. I have this interesting video about, it's a little bit graphic, but it's really good to see. This is the mite is here. This is the mite. I know it's graphic, but it's interesting to see how they work, these biological controls. Once they invite other mites, and then they start eating this larvae in group. Even this company, the Corbett company, sells this mites for introduction. To 28 minutes later, they almost kill that larvae and almost finish eating, and then they have to go to look for other larvae. All right, so these are micro-hilled mites, and also there are other mites in poultry operations. Arpolid mites, also they are very effective against first instar larvae. The other common biological control in poultry operations is Hister beetles. Hister beetles are a small black beetle, approximately 1/8 inch long. As you can see here, both adults and larvae feed on housefly eggs and first instar larvae. Like micro mites, Hister beetles do not seem attracted to fresh manure, and it may take 6 weeks for significant population of these Hister beetles to develop. So 6-week-old manure would support the good population of these Hister beetles. Another Hister beetle which is the lower one, Gnathnacus Namos is also present in lower numbers on poultry farms, but the most common one is this hister beetles. And then the problem with hister beetles, early in spring, they try to disperse. They try to escape from the poultry houses. So farmers or poultry producers has to have a black light trap with a tray on it, or a pitfall tray in between a manure mounds or manure corn. So the flies, when they get attracted to the black light, they will fall to the trap. So the trap will keep them inside. So every 3 days, they has to be collected and kept in an incubator or in a place where you can have 50 degree, where they can survive until the poultry house clean out. So this is a trap called a black light pitfall trap, which is used to trap the lister beetles or the beneficial beetles. Another very commonly used or commercially available biological control is tiny stingless parasitoids or parasitic wasps attack most of common manure breeding flies. These parasitoids are rarely noticed because they are extremely small, occur naturally in low numbers on many farms. They live in manure or other decaying organic matter and search for fly pupae. Adult female parasitoid lay an egg on a fly pupae when the puparium, as you can see here, both these 2 different species of muscadifrax. They are 2 different species, so they lay their eggs on the puparium or on the pupa of the fly, and then the egg hatches inside. The egg of this parasitoid hatches inside this puparium, and then the larvae enjoys the fly inside the puparium, and then emerges as an adult and fly and deposit their eggs on other puparium. Here, I just want to mention the male. This is what you see here is both females. The male relies on some excretes. They need sugar, some sugary substance. Some of them may go outside to look for sugar. So there are some juicy substance that supports the life of the male or adult females to survive in a chicken house. So because of naturally low parasitism levels, control programs are sometimes based on mass release of commercially rated parasitoids. These parasitoids normally being sold by IPM Laboratory Inc. I can share the link of this company, which sells different types of parasitoids that can be used for introduction in poultry operations. So the last resort of control measure is chemical control. So producers must monitor fly population on regular basis in order to evaluate, like what we mentioned before, we have to have sticky trap or jack bait trap, or this ribbon sticky trap, or different types of monitoring system. So based on those monitoring results, those producers has to decide when to spray insecticides. So accurate insecticide application rate record must be kept. Insecticide can play an important role in integrated fly management if it's used properly, according to the instructions, according to the label. Pesticides are part of, chemical pesticides are part of integrated pest management. Improper timing and indiscriminate insecticide use combined with poor manure management, poor moisture control, and poor sanitation practice will increase fly population, and indeed it will also increase insecticide costs. In turn, it increases production costs. Although most fly insecticides are toxic to predators and parasitoids and can result in their destruction if used indiscriminately. So those pesticides that we apply to control houseflies, they may also kill predators and parasitoids, which are beneficial insects, or other beetles. So that's we have to put into consideration before we apply. So extensive or improper use of pesticides result in destruction of biological control agents. That's an issue. Also, development of pesticide resistance. By the way, houseflies are really quick, very quick to develop pesticide resistance. Most of the time, the pesticide resistance is controlled by 1 or 2 genes. They just need to recruit in 1 generation or 2 generations, they will recruit this pesticide resistance gene. So pesticide resistance or development is an issue if we spray frequently or improperly. And also it has an issue of residue in meat and egg products, which leads to a legal litigation. And also contaminate the environment. Improper use of pesticide will get washed somehow and reach to the aquatic environment and might kill other organisms. And also fly resurgence. Fly resurgence means, as I have mentioned it here, flies, they can develop resistance. And also the pesticide kills the biological, the beneficial insects or the biological control. As a result, the next generation, the fly population might increase. That will lead to increased pesticide use, that will lead to higher costs or cost of production. So having said this, what are the pesticides that we can use to control flies in poultry operations? So there are different classes of pesticides. We call them like adulticides or larvicides. Always recommended. The recommended is adulticides, pesticides that controls the adults. Most of the time, the larvicide, pesticide that kill larvae, is not recommended because they are always in the vicinity where the beneficial insects dwells. So larvicides are not recommended, but if we must apply a larvicide chemicals, it has to be spot application, not blanket application. It has to be spot application or a kind of providing food that has pesticide on it or other types. And also some pesticide classified based on the way they can be applied. Some of them are spot spray or space spray. Some of them are baits, and then some pesticides are feed additives. So what are the pesticides which are registered in Maryland? If you want to see those pesticides registered in Maryland, I just want to walk you through the Maryland Department of Agriculture pesticide database search. So for example, I just want to start. You can go to this link on the Maryland Department of Agriculture. You just put this one, housefly, you just simply housefly, whatever insect you are interested to look and search the pest name. And then there are different laser housefly, and then let's just select one, housefly. So these are all the pesticides registered and approved in the state of Maryland. So let's just open one just to see what is that. If you want to see the active ingredient, what is the active ingredient? Just click this one. You can see the active ingredient, use it on this pesticide. And also, where do you want to apply it? Is that inside a poultry house? Maybe you can check also that one. Pest controlled by this product, site which this product may be applied. You can check here. Different sites, different rooms. This is also for the households. Stored food, warehouses. So there is, this database is really rich. It has a lot of information, and then it's also always good to be in compliance with Maryland pesticide use laws. So if you follow this one, so I don't recommend any brand that is registered or not. I will always leave to the producers to go and somehow look some of these registered pesticides. So another very important thing I just want to share is always read product labels carefully before applying any pesticide. Mix and apply as directed. Do not overdose. Do not treat too often, and follow all precautions, dressing code, goggles, and other. In case there is any emergency, you have to have a plans where to reach out. So having said this, I just want to have this fly management schedule. So in order to control flies, what we need to do before clean out, capture beneficial beetles, like what I showed you, the black light traps or any other methods, but try to capture beneficial beetles. Most of the time during clean out, these beetles, they disperse and disappear. So it's very hard to recruit back these beetles. So the first in your schedule has to be before clean out, capture beneficial beetles. And before bird placement, clean the house, of course, and then apply residual insecticides, insecticide that persists in the wall of the chicken house. Also have a plan to have drying fans. Every 60 feet of the chicken house has to have ventilation or fans. And then bird placement, place chickens. Check for leaking waterers, because when you place chickens, the waterers might be distorted, might be broken. So it's better to revisit and check for leaking waterers, and also turn on the drying fans after bird placement. And then after 1 week of bird placement, spot cards or sticky cards has to be placed in 3 places in order to monitor the fly population. Also daily is always to check any leaking water, any moisture source. And then at this time, you can order parasitoids from the available sources like IPM Laboratory Inc. And then between week 2 through week 6, spot cards has to be really monitored weekly. Again, walk through the chicken house, check for leaking, and also start releasing parasitoids, and also release the beetles which were trapped and kept at 50 degrees, and release them between week 2 and 6 in order to reestablish the population. Here, I just want to mention here, very important note. Those captured beetles or beneficial beetles, do not move them from one chicken house to the other or to other farm, because these beetles, even though they are beneficial, also they carry a lot of pathogens. So it's recommended these beetles to be used in one farm, not to move them from one farm to the other farm, because they are going to carry with them the pathogens, disease-causing pathogens. So that's very important. So when you release these beetles, beneficial beetles, release those beetles which are captured from that particular bird house. And also sometimes in week 2 to 6, you can assist drying with snow blower just to dry the chicken house. And in week 7 to 11, keep doing the spots card monitoring and check for leaking waterers. And also if the spot card levels reaches above economic threshold level, if the spot card levels are below economic threshold levels, you can turn off the fans. The reason that you turn off the fans, because the fans might blow also some of the beetles, the beneficial beetles, away from the chicken house. So that's very important to consider. And then in week 11 plus, just keep doing all the spot card monitoring, leaking check, monitor fly population, and also act as needed, whether you have to apply pesticide or not. With that, I would like to say thank you for listening. I really appreciate for the time, for the opportunity. And this program that we are working in, this project is funded by USDA, NIFA, the CPPM program or EIP program. And here are the references that I used to prepare these slides. And if you have any question, You can reach me out on this email address and phone number. Thank you. And I would be happy to answer any question that you might have.
Thank you, Dr. Zebelo. Does anybody have any questions? You talked about the biological controls. Now, I was just curious, like this is all new to me as far as I've never used them. And can you use them in combination, or you just pick one?
You can use them in combination. Of course, for those parasitoids, they compute one another. For example, the Raplos, they lay 1 egg per pupa. The other one lays 4 eggs per pupa. So they compute one another. It's recommended those parasitoids, you can choose either of them, but still, if you want to boost the population, you can use both of them.
Okay.
It depends what your purpose, what you want to do.
And now you mentioned about layer houses, but these can be used in broiler houses as well, right? And
yes.
You would put them in the house?
Yeah, the only thing is always for the parasitoid, for example, you have to consider you have to have like 4 to 5 week manure. 4 to 5 week old manure.
Okay. Dr. Zebelo, can you share that site you said where you would order those?
Yeah, I can share that one.
Okay. That would be great.
Yeah.
I think a lot of people would be interested in the biological control.
Yeah, I think also they are really sustainable. Once they introduce, they can stay a little bit longer as long as there is enough manure with a good moisture level.
Okay.
Do you know how much those cost?
It varies.
We can look it up, but I was just curious.
It varies. I think it's been a while. I think when I was in Alabama, we purchased for some experiment, but it's been a while since I purchased from them. But I'm sharing the website here.
Okay.
That'd be great. And Dr. Zebelo and Jennifer and I, John, I'll be working on some fact sheets to put all this information together and get it out. But Sheila will still follow up and share it on our website and share all this information today.
Right.
But,
yeah, I just shared the website in the chats.
Okay, great. Thank you.
Yeah.
Yeah, and I have another question.
Yeah.
Now you might have hit on this, but I might have missed it. So like once we, purchase, is it a one-time purchase, or would you have to kind of reintroduce them into the house every couple of years, or?
I think you have to reintroduce, because sometimes when you clean out, the houses, you may lose a very significant amount of them. So whenever, if you have really maintained the manure for a long period of time in your poultry house, they may stay there for long, but normally during cleaning, the population reduces significantly. So
Okay.
reboosting is recommended.
Great information. I think
it is.
Things we can all learn, and we may come back and maybe revisit this since we're going to run out of time, Jennifer. Maybe we could do just a question and answer.
Yeah, of course. Now we are talking just about one pest. Of course, there are also other pests like what I mentioned, the mealworms, the mites. They have their own method of control, preparation, cleaning, and sanitation. Basically, the same, but they have their own threshold level. So we may have that chance. Sometimes we can talk.
Okay.
But I don't know if you saw, someone did ask, is there a manual of this IPM process and management tree?
Honestly speaking, I collect this information from different sources mainly, but we are putting together a website here at UMES supported by this very project. So this information and plus other information will be available on that website once launched.
Great.
Good.
Thank you.
Yeah.
Does anybody have any other questions?
I
Got a couple
could ask one.
Okay.
Hi. I'm more of a backyard hobbyist as opposed to high production. And I was wondering if you would have any adjustments to your recommendations in regard to somebody with just 12 chickens or something.
I think, yeah, what I would say is whatever recommended by for example, the parasitoids and the beetles, especially the parasitoids, when you buy them, there is a recommendation table. How many parasitoids you will need for how many birds. So that is always calculated. So you can downgrade that level if you have a very small bird house. You can introduce based on that requirement. There is a table that I have seen. I can share with you that table, so that based on that one, you can calculate how many batches of parasitoid you can buy in order for the size of the poultry production that you have.
Thank you.
Welcome.
Before we get off, Sheila or Jenny, when is our next grower lunch break?
We don't have a topic at this point.
Oh, okay.
But, June 1st is
June
the first
1st.
Wednesday. Yeah.
Okay.
So we'll have flyers coming out, hopefully.
Yes. If
Okay.
anybody has any ideas for topics, please send them to us.
Yes. Do you have any ideas? Well, if nobody has any questions, I would like to thank Dr. Zebelo. That was great. I have
Yes.
got a lot of other questions. So thanks for everybody for participating. And this recording will have, Sheila, you'll have this recorded as well too for folks to go back and view.
Yes. Mhm.
Don't forget to stop the recording.
Yes.
Yes, I was just looking for that as
Okay.
well.
All right.
Thanks.
See you all. Thanks.
Thank
Thanks,
you.
Dr.
Thank you,
Bye.
everyone. Thank
Bye.
you, Dr. Zebelo.
Bye. Thank you.